Hi everyone. My name is Marilena Pagano and I am the application specialist at Hellma. Today, I would like to welcome you to our third webinar of this year. My guest today is spectroscopy specialist Andrea Filippi on the topic how to minimize non-conformities in the production of edible oils and increase process control with VIS-NIR spectroscopy. Today's expert, Andrea Filippi, is a spectroscopy specialist and technical director at Hellma, Italy. In his role, he is responsible for the sales development and support of fast UV-Vis and NIR analysis solutions for laboratory and online applications in the industry. I'm glad he found the time to share his experience with us today. Welcome, Andrea.
Thank you, Marilena. Thanks to Hellma for the invitation. The title at this point may end with a question mark. How to minimize non-conformities in the production of edible oils and increase process control with VIS-NIR spectroscopy. We'll start with a quick introduction about edible oils. What are they and which are the wet chemistry parameters of interest? Why should I consider an integrated solution as an added value? And we'll explain it with a real-life example. This is a list of the most common edible oils. Fats and oils are mainly made up of a mixture of triglycerides. Triglycerides are free fatty acids with a head of glycerol. Fatty acids are chains of single or double carbon-hydrogen molecular bonds. The difference between oils and fats is the melting point at room temperature. Oils have more unsaturated fatty acids with CH double bonds. Biodiesel is fatty acid methyl ester. The most important constituents analyzed in plant-based oils. Here, moisture and free fatty acid are important trading parameters. Iodine number and fatty acid profile are the identity card of the oil. Light color and transparent is a typical feature of edible oils. Detection of peroxide gives the initial evidence of rancidity in unsaturated fats and oils. Other parameters are related to specific productions and destination of use. In a schematic representation of the production phases of edible oil, the raw material of origin are oil seeds. After pressing and solvent extraction, the result is crude oil. The first stages of refining are centrifugations with a mix of water, caustic soda, and acid corrections. Subsequently, we find the discoloration with clays and the deodorization in the column at high temperatures. So I get refined edible oil. Analysis of crude oil and refined oils are not enough to run a plant. Some intermediate steps are essential to correct large quantities of possible non-compliant product. Depending on the plant, production could take more than 8 hours. There is no need to monitor constituent in each production step. On crude oil, moisture and free fatty acid helps to set the recipe and evaluate losses. Between the centrifugation phases, the Effectiveness of the treatment is verified by keeping under control moisture, free fatty acid, and the production of soaps that are free fatty acid in reaction with caustic soda. Surely, the color measurement is the success index of the bleaching treatment. The iodine number and the fatty acid profile are fundamental in the control of blends or production changes between oils of different origins. It helps to choose the best moment for the storage tank switch. Most of the wet chemistry for edible oils are titrations and gas chromatography tracings. All laboratory reference analyzers require reagents or sample manipulation, skilled operators, and a lot of time to get results. They also require a suitable laboratory for a proper installation. Time, reagents, skilled operators, high maintenance costs, and limited number of samples per day. The sum of all these factors may be resumed in a simple word: cost. Our approach to process analytical technology involves three fundamental steps. Step 1, definition of the parameters of main interest. Step 2, survey on the availability of these reference data internally or in outsourcing. Step 3, definition of the calibration development protocol. The perfect solution that allows us to change our initial question mark into an exclamation mark is represented here. The challenge: correct hardware and smart sampling accessory, powerful software, flexible chemometric software, calibration improvement protocol, and 1-year technical support. I personally believe that the calibration improvement protocol combined with a year of technical support is the best strategy to achieve excellent results in synergy with the customer. For the hardware, our choice fell on a VIS-NIR diode array spectrometer covering wavelength range from 380 nanometers up to 2200 nanometers. Halogen lamp source, of course. Hellma analytics fibers and 3A immersion probe with 5 mm path length for a good analysis of liquids in transmission. The configuration must be well integrated with the process control system. A powerful software with wide availability of communication protocols and easy to use setup makes the difference. The hardware can be installed online for real-time process control, at line, close to the process line, or offline in the lab. The benchtop solution gives operators freedom to collect samples from the plant, a tank track, or oil silo tank. Benefits are instant: fast, reliable results in few seconds, easy to use because the operator have just to monitor a screen, no maintenance. The only yearly spare part is the halogen lamp to be replaced. The flanged probe is installed in the pipe and the instrument is placed inside an ATEX cabinet. For the benchtop configuration, a custom heated cup holder has been designed to keep the samples warm between 40 to 60 Celsius degrees. In this application, the main constituents for the online control are iodine value and the Lovibond color. Also, moisture, free fatty acid, and the fatty acid profile have been absolutely calibrated with robustness and reliable results. This is the spectral database in the near-infrared region. The information on the carbon, hydrogen, oxygen molecular bonds is distributed over the whole range, but especially between 1700 nanometers and 2200 nanometers. The chemometric study in agri-food products, differently from pharmaceuticals and chemicals, must necessarily consider the heterogeneous nature of absorption overtones. Each constituent requires a full range development model. Color calibration works best in the visible range. These spectra could be mistakenly assumed to be in absorbance. The problem is the Lovibond reference method, which cannot be physically reproduced with an optical path of 5 millimeters. The typical approach of the NIR range was therefore chosen. The match between reference analysis and spectrum of the same sample. The circle highlights the spectral response of a sample with high yellow and red indexes. In the iodine number calibration, population is concentrated in the values around 30s and 60s in iodine number. We could have defined two extremely precise calibration, but we would have lost the ability of the calibration to discriminate non-conformities and production changes on the same pipeline. The decision to extend the sampling to values outside the production norm has made it possible to maximize correlation with positive reinforcement on performances. Tolerance is absolutely within the acceptability. A derivative pretreatment is applied to the spectrum. The standard normal variate approach effectively removes the multiplicative interferences of scatter and particle size. Detrending accounts for the variation in baseline shift and curvilinearity. These are typical setups for NIR calibrations. Please notice the high number of samples. We are around 900. In the case of color calibration, samples are few, and the database must be populated. This is a non-conventional approach in the VIS range, but it pays. Thanks to samples with high red and yellow index, also these two calibrations get better performances, maintaining high correlations instead of searching the lower standard error of calibration. Online measurement are averages of spectra accumulations and results moving averages. Long-time measurement trends are significantly more effective and representative than ultra-precise single-spot samples. So the calibration performances accomplish the precision target even if the color should be integrated with more reference data for robustness improvement. Customer experienced the decrease of non-conformities. The process control system integration through open platform communications protocol increased ability of fine-tuning of the production. Benefits of quality control 24/7 against the risk of collecting non-representative spot sampling had a positive effect also in lowering the pressure to the lab data productivity. The return of investment is incredibly fast. And that's all about how to minimize non-conformities in the production of edible oils and increase process control with VIS-NIR spectroscopy. Thank you for your attention.
Thank you very much, Andrea, for this very interesting presentation. So, during your presentation, there were some questions from our audience, and I have picked out some, and I am curious to hear the answers. So, first question will be, how long did it take to create the model, and how quickly does it pay for itself?
We started with the feasibility test with some database that were not completely fitting the representation of the samples of the customer. So we decided to, with the customer, a campaign of sampling collection that takes about 1 year. We were able so to collect reference spectra of the customer and also collect some artificial samples created with the customer to amplify the wide the range of the samples for the calibration. The payback was quite immediate, let me say.
And the second question is, how long has the method been running? And can you tell how often it needs to be recalibrated?
Okay. Actually, for all the configurations, and I mean online, at line, and benchtop in the lab, it's 8 years, still working with satisfaction. And let me say that calibration don't needs to be frequently updated. There are some parameters typical of the chemometrics that are the global distance and the neighbor distance that we use to select specific samples that are useful to improve the calibration performances. So we are talking about few samples per year.
So the last question is, where is there potential for savings? Only in reduced laboratory and personnel costs, or also in scrap reduction and improved production times?
The most important and immediate benefit was on the pressure on the laboratory for data production. So, of course, benefit costs and time savings are in that specific field, so the laboratory. But of course, the online implementation lets the manager of the plant to get a very lower and to lower the non-conformities in the production. So the amount of correct product production has been increased.
Really, really good. Andrea, thank you very much for the answers and for the presentation, of course.
You're welcome.
The next PAT webinar will take place in October 2023. You will be informed in a timely manner via our newsletter about it. So for the latest updates, please feel free to follow us on LinkedIn. Thank you very much and have a nice day.